Hello and welcome to our lesson on relative formula mass, sometimes also referred to as relative molecular mass. Okay, let's look at the information. Question is, what is the relative atomic mass of carbon? Is it 6 or is it 12? Well, hopefully you've remembered that the larger of the two numbers is the relative atomic mass, and so carbon has a relative atomic mass of 12. Okay, so what's the relative atomic mass then of oxygen? Well, hopefully you would recognise it's the larger number, and so oxygen has a relative atomic mass of 16. So if these two were bonded together to make a molecule of CO, so carbon monoxide, what do you think the relative molecular mass of carbon monoxide would be? Is it 12, is it 16, or is it 28? Well, if you add them together, one carbon with a mass of 12, one oxygen with a mass of 16 gives a relative molecular mass or relative formula mass of 28 for carbon monoxide. So we're simply adding them up together. Okay, what about this one then? What's the relative molecular mass of carbon dioxide with two oxygens and one carbon? Is it 28? Is it 44? Or is it 36? Well, I've got two oxygens here and I've got one carbon. So the relative molecular mass or the relative formula mass of carbon dioxide is 44. So let's take a step back. What if you just had the formula? So here's a well-known formula, water, H2O. What does that tell you about the atoms in that molecule? How many hydrogens do I have? Well, I have H2. That 2 belongs to the hydrogen. I have 2 hydrogens. And how many oxygens? There's no number next to the oxygen, so it's just 1. Do I have enough information now to figure out the relative formula mass or relative molecular mass? Nope. I need to go to my periodic table and look at the relative atomic mass of those two elements. So what's the answer then? The relative formula mass of water, H2O. Is it 17? Is it 18? Or is it 33? Well, I'm hoping that most of you have got the answer 18. If you got 17, it's because you forgot to add 2 hydrogens. And if you got 33, it's because you had 1 hydrogen and 2 oxygens instead. You need to read the formula very carefully to make sure you're getting the right numbers of the right atoms. What about if I had 2 molecules of water? What's the relative formula mass of 2 molecules of water? Well, I know that the relative formula mass of 1 molecule of water is 18. So that's that one there. But this second water molecule also has a relative formula mass of 18. And so the total would be 36. I would add those two together. Now, how would that show on my formula? Well, what happens is that 2 comes in front of the entire molecule. So I've got 2 lots of H2O. Okay, so pause the video and have a go at figuring out how many atoms of each element are in these formulae. All the information's on the page for you, so you don't need to go elsewhere to find a periodic table. Okay, so the first one was done for you there. Carbon dioxide, CO2, I have 1 carbon and 2 oxygen. For HCl, I have 1 hydrogen and 1 chlorine. For calcium carbonate, I have 1 calcium, 1 carbon and 3 oxygen. And for iron oxide, I have 2 iron and 3 oxygen. Okay, so taking this a little bit further then, now we know how many atoms of each element we've got, can we calculate the relative formula mass or the relative molecular mass for each compound? And notice I've done the first one for you as an example. Carbon dioxide is 12 plus 16 plus 16 gives me a relative formula mass of 44. Pause the video and have a go, please. Okay, so HCl, I've got 1 hydrogen with a mass of 1, 1 chlorine with a mass of 35.5, so a relative formula mass of 36.5. For calcium carbonate, I have 1 calcium, so that's 40, 1 carbon with a mass of 12, and 3 oxygen with a mass of 16, so that gives me a total relative formula mass of 100. For iron oxide, I've got 2 ions, each with a mass of 56, and I've got 3 oxygens, with a mass of 16. That gives me a total relative formula mass for iron oxide of 160. That's it for this lesson, guys. I'll see you later.